Yes. Uh, I hope you remember from last day's work. This was our first equation with the blue arrow, second one, third one, and fourth one. For the fourth one, the equation is not written in the book, and I asked you to write it on your books. So this is a four-step question in which all steps have at least one equation and a few conditions or name of reactants or products to mention. All right, I hope you understand that. If not, let me know, I can explain it more.
No, sir.
No means you did not understand it, or no means I did not need to explain it more. No means what, beta? I'm waiting. Explain करने की जरूरत नहीं है. Students, मेरी आवाज आ रही है?
Yes, sir.
Yes, sir.
Sorry, I get disconnected due to the internet. ठीक है, where were we?
सर शुरू करना था हमने.
अच्छा, चलें. Just a second. So starting with today's work, I was about to revise you from yesterday that this Chlor-Alkali industry had three products. ठीक है? The first one was chlorine, the second one was hydrogen, and the third one was sodium hydroxide. So what we are going to do is that we're going to go for the uses of all these three products in detail and some other ones as well. Okay. It starts off with the uses of chlorine. That's very easy. It's used in water treatment for both domestic water supply and swimming pools. For domestic water supply, we're not using chlorine anymore, but for swimming pools, we still use chlorine because for domestic water supply, chlorine tends to be a little bit harmful, but for swimming pools, it's good enough. Means in swimming pools, if it's chlorinated water, the only thing that is going to happen to you after a few minutes of swimming, 20 minutes, 30 minutes maybe, that you'll get a little bit of red eyes. That's about it, which will come clean after some time. But there are no other known disadvantages. Chlorine is used in the manufacturing of bleach. Bleach is something that can convert a colored substance into a colorless substance, and to make the plastic PVC. Polyvinyl chloride. This PVC plastic manufacturing is a part of chapter 11. So here they don't explain it anymore because they're going to explain it in chapter number 11. Okay. taken together, the halogens are very important, not just chlorine. So we need to discuss their wide use in polymers, solvents, bleaches, disinfectants, and the list goes up. They're all summed up on the next page. So moving on to page number 242, the three main products and their uses from electrolysis of brine or from the chlor-alkali industry are given over here. All right. So starting off with chlorine. Number one, it's a poisonous yellow-green gas. We already know about that. It's used for polyvinyl chloride or PVC. We also call it polychloroethane. It's a
Sir,
solvent for dry cleaning, right? जी.
सर हमने पहले पढ़ा था इसको पेल ग्रीन गैस, तो सर ये दोनों कलर्स।
हाँ जी, तो मैंने कई मर्तबा बहुत सारे कलर्स और उनके शेड्स बताए हुए हैं कि वो ओके होते हैं लिखने के लिए. So whether you write pale green or yellow green, both are correct. Like orange red
ओके
and brown red, both are correct for us. ठीक है? So you might
ओके सर।
write a shade, और मैंने क्लास में पहले भी कंफर्म किया हुआ है कि जो शेड्स होते हैं उन्हें यूजुअली एक वर्ड से या एक चीज से एक्सप्लेन नहीं किया जाता. ठीक है, हम उन्हें बहुत सारे तरीकों से एक्सप्लेन करते हैं, तो आप उन्हें किसी भी तरह से बता सकते हैं. ठीक, but they should be the allowed methods. ठीक है, never come up with something out of the ordinary or some other color that is not mentioned in any of your books or reference books, or आप कोई नया color उठा लाएं. For example, somebody is talking about light blue. You may write light blue or gelatinous blue, or you may write pale blue, or you may write sky blue. But one person comes up with the color turquoise. So you're not going to come up with something out of the ordinary, but odd, in other words. ठीक है? But you may use any of the relative words. ठीक है? You're going to clarify it later. ठीक?
Yes sir.
Moving on. They are solvents for dry cleaning. I hope you're familiar with dry cleaning, but we are going to explain that in chapter number 10. Uh, Paints and dyestuffs means colored materials, then bleaches, weed killers, and pesticides. I hope you're familiar with bleaches already. Weed killers means weeds are the plants that we not need with our crops. So something that kills weed is known as weed killer. Pesticides are the insects that eat up or are usually dangerous and harmful. So the chemicals that kill pests are known as pesticides. And harmful insects are commonly known as pests. All right. Hydrogen chloride, HCl, when dissolved in water, this gas becomes hydrochloric acid. So both hydrogen chloride and hydrochloric acid, this is the difference that we clarified back in chapter number 5. I hope you remember that. And killing bacteria in water supply and swimming pools. Okay? That would be the uses of chlorine. When we talk about sodium hydroxide solution, it's alkaline and it's corrosive. It is used for making soaps, detergents. This was previously a part of chapter 10, but it's not a part of chapter 10 anymore after 2016. Okay? So textiles and paper, right? These are the uses. Hydrogen is a colorless flammable gas. We already know about that. Hydrogen burns in air, burns very quickly, burns explosively, hence the word flammable. It's a colorless gas. We already know that. How to make margarine from hydrogen, like blue band margarine. We'll discuss that in detail with reactions, with conditions in chapter number 10. How to make nylon from that, we'll discuss that inshallah in chapter number 11. And how to make hydrogen chloride and hydrochloric acid from hydrogen, we have discussed that back in chapter number 4 as well as in chapter number 5. All right, so these are the uses of chlorine, sodium hydroxide, and hydrogen. That has been a common question in past papers, in theory paper, as well as in MCQ paper. However, where colors or flammability are mentioned, that has been a part of practical paper as well. So these are very easy questions. You memorize the usages and you write the usages in the same wording, you get the marks. Anything you'd like to ask before we move any forward?
No sir.
All right. The class seems to be small today. Okay, continuing. Let me just clear all the blanks. We were talking about the uses of all the halogens. So in case of halogens, let's go through the uses. We already know the uses for chlorine, so we're going to skip this part, but we're going to go with fluorine, bromine, iodine. Step by step, fluoride is present in toothpaste. All right. Most of the toothpaste that we use, it's clearly mentioned on the toothpaste that it's a fluoride toothpaste. Drinking water also contains some fluoride ions. That is also mentioned on the bottle. If you pick up a Nestle mineral water bottle, you'll find that written over there. PTFE or polytetrafluoroethene is actually a polymer. We'll discuss its making, conditions, everything in chapter number 11. It's a non-stick coating and it's used to make non-stick utensils such as non-stick saucepans or non-stick frying pans. Okay. I hope you're familiar with the word. If not, let me tell you, at least one or two members in your house or your housemate is probably using this to fry you an egg every morning, possibly. Okay, provided that you like or you eat eggs. Bromine are flame retardants. Flame retardant is something that can retard a flame or stop a flame or get flame to a smaller size. Hence the word flame retardant. Okay. Pesticides, yeah, we know all the halogens are extremely poisonous, so can be used as a pesticide. It's a petrol additive. It was previously a petrol additive. It is not used as a petrol additive anymore because that has become now questionable in the modern world. Now, it is used in photographic films. This is something we studied back in chapter number 7. A little revision. Bromine, if used in photographic films, can be used those photographic films for high quality photography or for commercial photography, because commercial photography is usually a high quality photography. All right. Moving on with iodine, it can be used as an antiseptic. Antiseptic is something that we use on wounds so that the germs or microbes could not attack wounds. Once again, if they are poisonous, then that can be used for closed wounds, but it cannot be used for open wounds. Even if it's used for open wounds, the wound has to be first cleared up by some kind of source or some kind of water or solutions before iodine can be used as an antiseptic. If any of you has ever been to emergency or right after an accident, okay, you might have experienced orange brown color solution that is used by that emergency department as a first aid, and that orange color solution usually is marketed in Pakistan by the name of iodine, is actually an iodine solution and used as an antiseptic, just to make sure that if you had a wound from that accident or incident, it is not attacked by microbes and it does not go bad. Iodine is also used in photographic films. Okay. Once again, it's a revision back from chapter number 7. We studied that if iodine is used in photographic films, it can be a high quality photography, but there is one specific point to it. It can be used for high speed photography. High-speed photography is a type of photography in which we take pictures after a matter of seconds and we keep on taking pictures, or we keep on taking pictures with such a low time frame that it becomes a video. So yes, iodine was used for that purpose. Okay, is still used for that purpose if proper photographic films are used. Okay, remember, a photographic film is used if you're going to take a photograph in terms of a proper hard copy. Okay, if you don't use photographic films, nowadays we have software based systems, so they simply just store it digitally. There are no hard copies for that purpose. Okay, for example, your cell phone camera or your digital cam is one of the cams that work completely digitally, and they do not go for any kind of hard copies, though they store their data on some kind of storage device, but it is still not considered as a hard copy until and unless there is a film involved, there is a reel involved. Okay? By film, I mean photographic film. And iodine is also used to make paper. Once again, it's a bleaching agent, so it can be used instead of chlorine for the making of paper. Okay? If you have any questions, please ask. Otherwise, we're going to just jump to the next topic, the second last topic of this chapter, limestone. See any questions?
No. सर इस इंडस्ट्री का मकसद यही चीजें ये 3 चीजें बनाना है जो ऊपर है फिगर में.
Yes, the one on the top figure. These
हाँ.
3 things. And by this industry, we mean the Chlor-Alkali industry, or the industry that goes for the electrolysis of brine. And by 3 products, I mean hydrogen, chlorine, and sodium hydroxide.
तो सर ये हैलोजेंस का यहाँ पे क्यों कहता है वो?
As there is this chlorine, because we were actually electrolyzing sodium, we were electrolyzing brine. If we go for another salt of sodium, let's say we do not go for that, we go for sodium bromide or sodium iodide, we might be able to get bromine and iodine. So of course we can use different halogens. Plus the uses of halogens are important, and we have discuss the uses of halogens back in chapter number 3. Once again, at this point, at this stage, halogens are considered to be the most important ones to be a part of your course. That's why we are repeatedly talking about halogens in most of the chapters of this book. Hence, halogens and their uses. ठीक? Anything else?
No sir.
All right. Girls, do you understand the topics, specifically the uses of halogens and the electrolysis products?
Yes, sir.
Aren't there 2 girls in the class? I only hear one yes. Let's make sure everybody's here, and let's make sure that everybody's awake. So let's go for a roll call. Kabir, you there? You need to write it in the chat. Yes, I'm here. Vase, are you here? Say yes.
Sir.
Okay. Ayan,
Yes sir.
Rafe, if anybody's mic doesn't work, go ahead to chat and write yes over there. Shazeb,
Yes.
Zaim,
Yes, sir.
Tanisha,
Yes, sir.
Zainab,
Yes, sir.
Zoha, Zoha, you here? If your mic works, fine. If it doesn't, write it in the chat. Yeah, Zoha, you're trying to speak, but we can't hear. So why don't we write it in the chat? See? Okay. Let's just extend it a little bit. Let's just make sure that you understand it. Okay. Although the page is right in front of you, but I'm going to ask you a couple of uses of each one. Okay. You have books in front of you. You have the page in front of you. Whether you use your book, whether you use this screen, you're going to tell me at least 2 uses for anything that I name. Starting with Tanisha. Tanisha, 2 uses for bromine.
Pesticides and photograph film.
Right. Zainab, what about iodine?
So photographic film and paper and antiseptics.
Good.
Antiseptics.
Yeah, just 2 uses are enough. Kabir, why don't you write 2 uses of chlorine? Rafi, why don't you write 2 uses of fluorine? Ahyan, what about the uses for hydrogen?
So used for making nylon, hydrogen chloride and hydrochloric acid.
Yeah, that's good
so,
enough. Just 2,
it's-
just 2. Take it. Let's just stick it to 2. Acha. So next person is Vase. Vase, what about sodium hydroxide?
So it is used in making soaps and detergents.
All right. Zaim, what about iodine?
So antiseptics and photographic film.
Mm-hmm. Good. Shazib, what is an antiseptic? Rafe, please write in chat. What is detergent? Kabir, please write in chat. What is dry cleaning? Okay. Gee, Wasi, coming back to your question. Wasi, if your mic works, say it out loud. If not, then you can write it in the
Yes.
chat.
Yes, sir, it works. Yes, sir.
What was the question? I forgot the question, Wasi. What did I just ask you? Or did I forgot to ask?
So I think so about detergents.
Huh. What is a detergent? Yeah. Yeah, good. You remembered.
Detergent. So they are used for cleaning.
Yeah, they're used for cleaning. Very good. The chemicals that are used for cleaning purposes. Okay. Tanisha, why don't you tell us what is a flame retardant? I'm asking you things that I just explained, so just you can just repeat my words and you can tell it in your own words. I'm fine by both. G.
Sir, which stops the flame?
Good, good. Zainab, you would see on your screen the uses for chlorine. Here, use is mentioned PVC. Where is PVC used? There are a few names mentioned over here. Why don't you find them and say them out loud? Zainab. Zainab, can you hear us? Zainab, beta, can you hear me? All right. Kabir, why don't you answer the same question in chat? The question was that we have in table number 9.3 a use for chlorine that it is used to make PVC, but then PVC is further used to make more stuff. What is that more stuff? Okay. So Rafiq, you're going to write in chat that both bromides and bromine and chlorine are used for photographic film. So what's the difference? I cleared out the difference. So you're going to write that in chat. Good work, Habib. Zanabeda, if your mic is not working, you can also write it in chat. Write the answer to the same question in chat. किसी का भी mic work नहीं कर रहा है, simply अपना answer chat में लिख दें, कोई मसला नहीं है. I'm continuously reading chat, so it's not a problem. Okay, so Shahzeb, there is a figure right in the center of this page, 9.24. This figure talks about why chlorine is used to treat water. So you're going to answer us why. Why do we use chlorine to treat water? Or how chlorine treats water, by doing what? Shahzeb.
वो बैक्टीरिया को मार देते हैं.
Good, good. Just bacteria or harmful bacteria?
Harmful bacteria.
Yeah, right. Actually, just bacteria was good enough. It kills all kinds of bacteria, whether good or bad. See? So you were right in the first place. But yes, you may write harmful as well. Okay. So that means we are all awake, we're all studying, and we're all getting the point. Okay. It was a simple activity just to make sure we're all here, we're all studying, and we're all focusing. Good work, Rafi. Yes, that's correct. Okay. Okay. So I hope the topic is very clear. We have gone with our question answers. So let's move on to the next topic, 9.6, second last topic of this chapter, limestone. So talking about limestone, limestone is quarried. Actually, these are rocks, stones. The stones are always quarried, which means stones are broken down from very, very large pieces to smaller pieces. And by, I mean, very, very large pieces, actually, they are sometimes present in the form of mountains. So the entire mountains are broken down into bigger rocks, and then bigger rocks into somewhat less bigger rocks, and the somewhat less bigger rocks into smaller ones. And we get it broken down all the way to a fine powdered form for our use. So yes, it is quarried in large amounts worldwide, let me tell you, the earth is filled up with limestone in many different forms. We studied back it in chapter number 5. Let me revise. Limestone is present in the form of chalk. I hope we are all familiar with chalk. Limestone is present in the form of many different, colorful, attractive kind of marbles. So marble is one of them, or tiles are one of them. The ones that we use to make floors in our houses or in our mosque or in our shopping centers and stuff like that. So it is present in different forms, and limestone is what eggshell is made up of. Okay? Lime or calcium is something that our bones are made up of and our teeth are made up of. So limestone is very important. This limestone is actually converted into many different forms, and the calcium is then used for strength of structures. Remember, if we are talking about presence of calcium in some structure, like we do in limestone, the structure must get some strength. It must have some strength, because calcium is our representative of strength. Just like it is a representative of strength when we talk about the bones and the teeth of our body, because they are the most strengthened part of our body. All right. So limestone is used directly. Limestone can be used in other compounds. Limestone can be used as a raw material to make compounds. So there are many different uses of limestones. We're going to go through them step by step. Direct uses of limestones. Powdered limestone is often used to neutralize acidic soils or acidic lakes, or lakes acidified by acid rain. This is something that we studied back in chapter number 5. It is cheaper than using lime calcium oxide, which has to be produced by heating limestone, something we're going to discuss on the page after the next page. Okay? In blast furnace for the extraction of iron, limestone was used. Limestone was actually used in the blast furnace, not for the extraction of iron, but to remove the impurities that is found in iron ore. We called it slag. The impurities were then removed in the form of slag, which was known as calcium silicate. So these are the direct uses of limestone. Now, let me tell you, cement is also made up of by limestone. It is made up by heating powdered limestone with clay in a rotary kiln. You must ask me what rotary kiln is. So right after I read a couple of lines more, we're going to move on to the next page, and I'm going to show you the figure of a rotary kiln. This material is then powdered and mixed with gypsum. Gypsum is once again made out of calcium. That's why we see cement is so strong, so hard once it settles down. Take it once it's dry. So when water is added to this mixture, a complex set of chemical processes or chemical changes takes place, giving it a hard interlocked mass of crystals, hence cement. Okay? Of hydrated calcium aluminate and calcium silicate. Actually, actually cement, when it settles down and when it's dry, is a mixture of these two components. You may memorize these two components. Even if you don't, that's fine. We have seen that it is not so important, and plus it's a little bit more difficult when we talk about your level. So even if you do not memorize these two formulae, that's fine. And we have also seen that they are not part of past papers. Even if they come as a question in past papers, they're usually a part of statement of the question. So you do not need to show your memory about these formulas. Now, coming to the next step, we use cement to make concrete. Concrete is actually a mixture of cement and some aggregate material. That aggregate material may contain stone chippings, may contain gravel, may contain sand, may contain water. So there is an entire formula for that. Before we move on to this formula, what we are going to do is that we're going to understand this diagram that is given on the center of this page. The page number is, let me go through that is page number 243. Okay. Now take a look at the top of the diagram. You would see that we have taken powdered clay and limestone and we have mixed them, and then we send them into a rotary kiln. A rotary kiln is a kiln that rotates and the mixture moves along. So it mixes whatever we send is something in. Rotary kiln is made out of steel and it's about 100 meters long. So in cement industry, this is the longest structure. 100 meters is too long. 100 meter means we're talking about roughly 314 feet. a usual room or a classroom that you have is 12 feet, which means if we're talking about 320 feet, so we are talking about roughly 28 rooms like that. Okay? So you can say this kiln is about 28 rooms long. So that is a rough general impression or an imagination to make how long that kiln is. So that kiln is the longest structure in the cement industry. And let me tell you, this entire structure, no matter how long it is, it rotates. It rotates along its own axis, and it then mixes all the substances that are present inside it. And this longest structure in the cement industry is usually filled with tons of material, and that material is powdered clay and powdered limestone, which produces a lot of cement. Not just that, this kiln moves. Kiln is usually a structure in which we do not just mix the material, we mix them on a heated impression. So what we do is that we keep heating up this kiln. Not only it's moving or it's rotating around its own axis, it's mixing the material, it's also heating them up. So what happens is that hot clay and limestone react to make cement. We then grind this powder to make powdered cement. In order to make concrete out of this cement, we usually add some more materials to the cement. You would see that the bags of cement are then mixed with sand and gravel. Gravel is actually crushed mountain stone, and we add some water and we add it to a mixer. This is known as concrete mixer, which gives us concrete which is ready to use. This concrete is then used to make walls and floors and ceilings of our houses and other buildings. You know, the
Sir?
concrete mixture is usually very hard and strong, and it is able to carry weight. And you know, the concrete is something that we have been using from quite a while now, and we are making multi-story building from this concrete. But it's not just concrete by which we make a multi-story building. We are also going to move one step ahead. So the first step was taking limestone and converting it to cement. The second step was using more material with cement to convert into concrete. And now, in order to make a multi-story building which can bear a lot of weight, we are going to go move one step ahead, and we are also going to convert concrete into something else. GIR.
सर वो जब हम बना लेते हैं सीमेंट, मतलब उसको मिक्स भी कर लेते हैं,
जी।
तो सर वो जब वो सूख जाता है तो वो सख्त क्यों हो जाता है?
क्योंकि केमिकल रिएक्शंस होते हैं, ये नए कंपाउंड्स बनाते हैं. The formula for limestone is CaCO3, but you might have seen when it reacts with water in this material, the formula is different. Can you see the formula? It's calcium aluminate and calcium silicate. So these chemical reactions give us a hard interlocked gas. ठीक है? ये इस केमिकल रिएक्शन का असर है. अब हर केमिकल रिएक्शन का मुख्तलिफ असर होता है. कागज का जलना एक केमिकल रिएक्शन है, उसका असर आपने मुख्तलिफ देखा है. वो ऐश में कन्वर्ट हो जाता है, ब्लैक हो जाता है, साइज छोटा हो जाता है. ठीक है? गैस का जलना एक केमिकल रिएक्शन है. चीजों को हीट अप करने से, आपस में रिएक्ट करने से. अब हमने एसिड और अल्कली की केमिकल रिएक्शंस भी देखे हुए हैं. हमने बीच में इंडिकेटर डालते हैं, कलर चेंज होते हुए भी देखे हुए हैं. So it can be a change in color, it can be a change in state of matter, it can be a change in hardness or strength of substance, it can be anything. So these are chemical reactions by which we get this hard interlocked mass kind of result. Clear?
सर तो हम पानी क्यों डालते हैं उसमें?
Because water reacts with it.
Okay sir.
Water is a part of reactant. Water इसलिए ऐड किया जा रहा है कि वो रिएक्टेंट है. ये सारे रिएक्टेंट्स हैं. इसमें स्टोन भी रिएक्टेंट है, इसमें सैंड भी रिएक्टेंट है, इसमें ये सीमेंट भी रिएक्टेंट है, and water is also a part of reactant. So there are 4 reactants giving a single product that is known as concrete. It's just not just mixing. Let me tell you, it's not physical mixing. Yes, it is a mixture, but internally there are many chemical reactions as well. Same goes with cement and water. Cement and water can react chemically to give us the hard interlocked mass.
Okay sir.
Clear? Any other questions before I move any forward?
No sir.
Okay. So the mixture is mixed with water and then poured into wooden molds. It is then allowed to harden. And We also convert concrete into reinforced concrete. Now the question is, what is reinforced concrete? Reinforced concrete is another step in which we allow the concrete to sit around steel rods or steel mesh. Okay, do you understand what a mesh is? Okay, I think there is a diagram over here. Yeah, right. At the bottom of the page, you'll see the steel mesh. It's a networked structure making small squares inside, which is some free space, which can be filled up by using concrete. So this mesh is there, and this mesh is made up of metal rods. ठीक है, हम इसे अपनी कॉमन जबान में यहाँ पर पाकिस्तान में उर्दू में सरिये के नाम से जानते हैं. ठीक है, इस mesh को, metal rods के mesh को, ठीक है, and we fill it up with concrete in order to call it reinforced concrete. आप देख रहे होंगे ये इस वक्त